Well, I received your question. A simple random sample size of n is drawn from a population that's normally distributed. The sample mean is 112. The standard deviation, S, is 10. And you have several parts. I'll work the first part. You work the others similarly. Construct a 98% confidence interval about the mean if the sample size n is 19. Okay, I guess that'd be the population mean. Let's see. So they gave us that the sample mean is 112. The sample standard deviation is 10. The sample size is 19. Well, if the sample size is 19, that tells you the degrees of freedom would be n minus 1, which is 18. And you want a 98% confidence interval. So we don't have to use this table here to find the critical value here, t critical value. So we got to take 1/2 of 1 minus, change that to decimal, 0.98, and so 0.01. So we use the degrees of freedom. You'll need to click on this button, and the vertical column on the left will get degrees of freedom, so you go to 18, and then across the top you'll need to find 0.01, and you take 0.01, you go down to 18 degrees of freedom. And what you'll find in the table is that the critical value is 2.552. And so again, how did I find that? I used 18 degrees of freedom with 0.01 from this table. So now we know everything in this formula. For this formula, the minus gives you a lower bound and the plus gives you the upper bound. And so if I use that formula, and here's all the numbers. So the sample mean is 112. If I do the lower bound, be minus the 2.552, which came from the table, times the sample standard deviation over the square root of the sample size. So, here's the numbers for this formula. And they'll all come from over here in this value. And if you put that in your calculator and round to nearest nearest tenth, I believe I came up with 106.1. Now you just need to do this again and make that a plus instead of a minus for the upper bound. So it'll be it's a times 10 over square root of 19, and I believe I got 117.9. And so this is the upper bound, and this is the lower bound. Okay, and so I guess we can say with a 98% confidence that this interval here will contain the population mean. I hope this helps.